Hey guys, on to 7.3b, power to a power. Um, our objective here is when we're going to raise a power to another power. Okay, pretty crazy, crazy. Before we do that though, um, this is when we know we have successfully fully simplified um, an expression. All right. First off, there's no negative exponents. All right. So if there's negative exponents, it's not simplified. That's what this means. The same base does not appear more than once, meaning you can't have the same base in multiple places and say it's simplified. You have to figure out what you have to do in order to simplify it. There's no powers raised to powers, which we're going to get into in this lesson. All right. Then the next one, there's no products raised to powers. I'll get to that one. Then the next lesson. And the last one, there's no quotients raised to powers. All right. So we can't have anything pretty much raised to any powers. All right. So briefly, let's take a look. Oh, my bad. Sorry. Here we are. Why are these not considered simplified? So let's take a look at this first one right here. This one is not simplified because this -2, there's a negative exponent. All right. We could simplify that. Why is this one not simplified? I meant to do that in yellow. This is not simplified because we have the same base. Okay. This one's not simplified. This is what a power to a power is. When we have our original power, z cubed, and it's raised to another exponent, we call that a power to a power. Okay. This one here, going down on the list, this is a product, a times b, and that's to a power. We're going to learn how to simplify that in our next lesson. This last one, this is a quotient because I am dividing. I am dividing s by t and then putting it to the fifth power. I can simplify that. And this last one's a little bit trickier. I have 10a squared over 4b. All the bases are different. But what do you think we could simplify here? All right, yeah, we could divide the 10 into 4 and simplify it, treat it just like a fraction, and make that 10 into a 5 and that 4 into a 2. That's all we can do there, though. All right, but now let's get into what a power to a power is. All right, to find the power of a power, we kind of use what exponents are. All right, so here's my first example, 4 cubed squared. All right, what that means is this square on the outside means I want 2 of whatever's inside there multiplied together, like this. All right, that's what it means. I want a 4 cubed times another 4 cubed. All right, that's what, remember, exponent means multiply by itself that many times. Itself, this case, is 4 cubed. And now what that means is I do 4 times 4 times 4 times 4 times 4 times 4, right? And if you count all the fours, how many do we have? That's right, we have 6. So 4 cubed squared, that sounds really weird, I know, but 4 cubed squared, or pretty much 4 cubed to the second power, is equal to 4 to the sixth. Do you see a shortcut here? What that means is that we can just we can just multiply our exponents together if we have a power to a power, and that'll give us our new exponent. So here's the rule for power to a power. A power raised to another power is that base raised to the product of the powers. So many pieces, so much alliteration here. Look at me doing lit. But a to the m to the n, again, that's a to the m to the n equals a to the mn. What? Again, a to the m to the n equals a to the m to the n. You can read it. I'll stop messing you up. All right, let's do some examples. First one, 5 squared to the fourth. We could expand it all out and write 5 squared, 5 squared, 5 squared, 5. Let's not do that. What is the answer going to be? That's right. It is 5 to the 8th. What about 4 cubed to the 0? Oh, anything to the 0 power is going to be 1. Even if it's an entire power, it's 1. All right. And now this last one's where it gets a little bit crazy. All right. X cubed to the -5th and then times x to the 4th. So what I'm going to do first is just multiply my two exponents here, these two. It's kind of like distributing, okay? It's kind of like distributing. I'm distributing that -5 into that 3, but only the exponents. And then I still have times x to the 4th. Is this simplified? No, I have two of the same base. So now what I have to do, because this now goes back to our rule we learned yesterday, or not yesterday, the previous lesson, depending on what day you did this. I have the same base. I'm multiplying. So what do I do to my exponents? Hope you said add. So I get x to the negative 11th. But wait, I'm still not done. I have a negative exponent per the rules, not not simplified. I now have to do the reciprocal and make it a positive 11. So all of this simplifies down to that. Last example. Simplify me. Just kidding. That was funny. Not really. So now I'm simplifying this. This is kind of like two things in this. All right. First instinct. What do you think? If you got it wrong, no biggie. I'm not going to hold it against you. All right. But what we have to do here is each one of these is its own base. Each one of them have an invisible exponent of 1, meaning each one of them have to get this cubed. If I were to expand this, and this will be helpful to do it this time. If I were to expand this, I would do 8x times 8x times 8x times 8x. How many 8s are there? There are 3, so it's 8 cubed. How many x's are there? 3, so it's x cubed. The answer is 8 cubed x cubed, not just. I'm going to write this down and show you this is not good. This 8x cubed, no good. That exponent has to go to everything inside the parentheses. Remember that. And that's it. You're going to try out IXL V7 and your mastery check.